Okay, let's dive right into this explainer. Today we are grabbing Chapter 2 of 10th Standard Science and transforming it into a fast-paced, high-energy revision session. Look, if you've ever found chemistry a bit dry, well, get ready. We're breaking down acids, bases, and salts into the absolute essentials. We're going to use some brilliant memory hacks, look at real-life explosive reactions, and cover those high-yield questions the board exams literally love to test you on. Let's go. Imagine this puzzle staring at you in the exam hall. You've got three mysterious liquids. One is water, one is acid, one is a base. But you only have one single strip of red litmus paper. So how on earth do you crack the case without, burning your fingers? You definitely can't touch them. Well, it's like a logic puzzle. You drop that red paper into the tubes, the base will immediately turn the red paper blue. Boom, you found the base. Now you have a blue piece of paper, right? Dip that into the remaining two tubes. The acid is going to turn it right back to red. And the one left over? That's your neutral water. Mystery solved.
Section 1. Indicators. Nature's secret detectives.
To solve chemical mysteries like that, we need indicators. It's actually incredibly easy to memorize these synthetic and natural color changes for your multiple choice questions. You've got natural indicators like litmus, sure, but also synthetic ones like phenolphthalein and methyl orange. Now, phenolphthalein is completely colorless in an acid, but it turns a bright, vibrant pink in a base. Methyl orange? That goes red in an acid and yellow in a base. Examiners love dropping this exact information into multiple choice questions with missing blanks, so absolutely lock these colors into your memory right now.
Still getting tripped up by litmus paper? Here is a super quick memory trick. Just remember, A for acid turns blue to red. Acid, blue, red. Once you've got that locked in, you automatically know that bases do the exact opposite, right? They turn red to blue. Honestly, you'll never get that wrong on a test again.
Have you ever spilled curry on your crisp white school shirt? Total disaster, right? But why does it suddenly look worse when your mom tries to wash it with soap? Well, the turmeric in that curry is actually a natural chemical indicator. The soap she's using is highly basic, and when that basic soap reacts with the turmeric, boom, it creates a stubborn reddish-brown stain. So yeah, chemistry is literally happening right there in your laundry bucket.
Section 2. Chemical reactions, explosions, and pop sounds. Step by step, imagine dropping a metal, like little zinc granules, into a strong acid like sulfuric acid. It instantly starts bubbling rapidly. It's freeing up this mystery gas. Now, if you take that gas, pass it through a soap solution to make bubbles, and then bring a burning candle near those bubbles, pop! It famously burns with this highly satisfying pop sound. The moment you see or hear that pop in an exam question, you are 100% dealing with hydrogen gas.
Now, the absolutely crucial point here is a specific chemical formula. The CBSE board totally loves to test you on the tricky creation of sodium zincate. Back in 2018, everyone thought a base reacting with a metal was too simple to be on the exam. But when you mix a strong base like sodium hydroxide with zinc, it creates a really unique, complex salt, sodium zincate. That's Na2ZnO2, along with our old popping friend, hydrogen gas. Do not skip memorizing this formula.
Okay, what if an acid attacks a metal carbonate instead? If you ever read the words brisk effervescence on your exam paper, which really just means super fast energetic bubbles, and the question says it turns lime water milky, congratulations, you have just caught carbon dioxide red-handed. And here's a fun fact. If you keep passing even more of that CO2 through the milky water, it amazingly turns completely clear again.
This brings us to the ultimate safety rule of the lab. You must never, ever add water to a strong acid. Why? Because the reaction is highly exothermic. That means it releases a massive amount of heat. The sudden flash of heat will cause a dangerous, literal face-melting splash, and it can even shatter the glass beaker right in your hands. Always, always do it the other way. Add acid to a large amount of water, drop by drop, while constantly stirring.
Section 3. pH power, the secret code of everyday life. The pH scale is like a secret code measuring the power of hydrogen ions. It runs all the way from 0 to 14. The lower the number, the stronger the acid. So numbers closer to 0, those are dangerous skin-burning acids. 7, right smack in the middle, is totally neutral. That's your pure water. And anything above 7, climbing all the way up to 14, is a base, with 14 being incredibly strong.
Now you want to memorize these exact numbers right now because they show up on exams all the time. Tooth decay starts the exact moment your mouth's pH drops below 5.5 because bacteria are in there feeding on sugar and creating acid. And rain? It's officially declared acid rain when its pH drops below 5.6. Oh, and when your stomach produces way too much acid and you get awful indigestion, you just swallow a mild base, like an antacid, say milk of magnesia, to perfectly neutralize it.
Interestingly, nature actually uses this exact chemistry for literal warfare. If you get stung by a wild nettle leaf while trekking, it physically injects methanoic acid right into your skin. It causes an intense burning pain. But brilliantly, nature almost always grows a basic plant called a dock plant right next to it. You just grab that basic leaf, rub it on the acidic sting, and they neutralize each other. The pain just vanishes. Nature is wild, right?
Section 4. The Salt Factory High-Yield Exam Formulas.
When you pass electricity through a saltwater solution, which is also known as brine, you triggered the incredibly famous chloralkali process. For exams, this process is an absolute goldmine. It delivers chlorine gas at the anode and hydrogen gas at the cathode while leaving behind sodium hydroxide in the solution. Here is a massive exam tip. Do not mix up those locations. Chlorine is at the anode, hydrogen is at the cathode.
And that chlorine gas we just made? Oh, it definitely doesn't go to waste. It is passed right over dry slaked lime to create bleaching powder, known chemically as CaOCl2. This is your ultimate go-to chemical for cleaning laundry and textile factories, making paper perfectly white, and even purifying your drinking water from harmful germs. Next up, the sodas. Look, students always confuse baking soda, which is sodium hydrogen carbonate, with washing soda, which is sodium carbonate. To avoid mixing these two up, just remember this. Washing clothes requires 10 whole buckets of water. That's why washing soda has that 10H2O hidden right there at the end of its formula. Baking soda is what makes cakes soft and spongy, but washing soda, that's for removing the permanent hardness of water. Speaking of that hidden water, this brings us to the pure magic of water of crystallization. If you take dry-looking, bright blue copper sulfate crystals and heat them up, water vapor suddenly appears out of nowhere and the crystal turns completely white. It turns out, water literally hides inside these dry-looking crystals, giving them their specific shapes and vibrant colors. Add a few drops of water back in, and boom, it instantly turns blue again.
This exact same concept is why doctors use plaster of Paris. When you heat a salt called gypsum to exactly 373 Kelvin, it loses some of its hidden water and becomes calcium sulfate hemihydrate. That's plaster of Paris. Adding a little water back into this half-hydrated powder makes it rapidly set into a rock-hard cast. It keeps fractured bones perfectly in place while they heal.
Section 5, Super Revision and the Ultimate Memory Trick.
All right, we are in the home stretch of this explainer, so it's time to fully lock in your mastery. You might want to memorize this legendary, funny mnemonic right now. Kadar Nath Kamali Alu Zara Fike Pakatahe. Cute Haring Ayaga Arpitega. It is an absolute cheat code for instantly remembering the entire metal reactivity series from potassium all the way down to platinum. Memorize this single phrase, and I promise you'll never get a displacement reaction question wrong again. To wrap up, I'll leave you with this classic board exam puzzle to test your brand new mastery. If a mystery solution reacts with crushed eggshells and releases a gas that turns lime water milky, what is that solution? Well, think about it. What are eggshells made of? Calcium carbonate. And what reacts with a carbonate to release carbon dioxide? An acid. I really hope this session made chemistry a little less mysterious and a lot more exciting for you. Keep revising these core concepts, remember those memory tricks, and you are absolutely going to crush your exams.